Alright, today in this video I just want to do a follow-up video from my previous video regarding my Ryzen machine build, my new build. In this video I'm just going to do some basic performance testing. I don't overclock anymore. I did that before, but I've gotten to the point now to where I've realized that squeezing that extra few ounces of performance out of your machine, it just isn't worth the time and effort. Now I just buy the hardware that I know is going to do what I want it to do, and I run it at the specifications for the hardware that I bought. So as far as this build goes, I didn't do any overclocking. The only thing I changed for the most part is I made sure that the UEFI BIOS was up to date to the current version. Then the only modifications I made to the default settings was that I enabled the memory performance profile. As I said in my previous video, the memory that I purchased was a 3600 megahertz. So in order to get it to run at that rated speed, you have to enable the XMP performance profile. So that I did do. I guess from an industry standard they consider that overclocking, but to me that's the performance of memory that I purchased, so that's what I want to run it at, so I don't consider that overclocking. But I guess from a technical standpoint it is. The only other thing I've modified on from a UEFI BIOS standpoint, other from the regular default settings, is the cooling curves. I did modify those and manually modify them to the way that I want them. Not necessarily so much for sound, but basically for most optimum cooling as far as my standards go. So those are the only differences I've made. So for this video I just want to do some baseline performance, what I would consider real world performance testing, just to give everybody an idea of what kind of performance I'm getting out of this machine. As I said in my previous video, I'm primarily a Linux user, so I do all my performance benchmarks from Linux. I'm actually recording the video on the box that I'm doing the testing on, so the performance numbers that I'm going to display are actually going to be while the device is in use, so it gives you a better idea of I'm kind of intentionally degrading the performance numbers on purpose by making sure the system is under load. The reason I'm doing that is because my interest isn't in I'm not interested in showing off. I'm not trying to break any records or anything like that. I want to give you an understanding of what you can expect performance-wise on a day-to-day using basis. What it looks like when the system is actually being utilized for what I normally do, which is, again, like I said before, mostly productivity stuff. I do number crunching, things that require a lot of capacity as far as processing goes. So we'll just go through all the different performance tests, and I'll show you what I have. All of my performance tests are going to be done in Linux. I did do a time spy run on it in Windows, just for reference, so we'll look at the results of that too. So let's go through. First off, like I said, I use most of my stuff as productivity orientated. One thing that I do run in the background all the time is BOINC. I like using BOINC for stress testing and then burn-in, because if I run both CPU and GPU processes on BOINC at the same time, then it stresses the entire system, both graphics and CPU. So I like using that for that. Currently all I'm running on it right now is just CPU intensive stuff. So we'll see what it's doing with CPU wise. I'm not running any GPU stuff because right now I'm trying to cut some stuff back, but we'll still see what the performance numbers are basically while the CPU is being utilized by BOINC in the background. So we'll look at some of those things now. First off, we'll look at the BOINC results. Right now I'm running, like I said, I'm running some BOINC processing in the background, but right now it's all CPU utilization. So we'll look at what's going on right now. As you can see, on a regular basis, my machine basically runs with these settings. Right now, it's reading the hottest temperature on the sensors is about 82 degrees. It looks like it's peaking out at 82. Right now, it's kind of hot in my room. The ambient temperature is kind of high right now. So normally I'm running right about 80 degrees with the normal ambient temperature. The highest I've ever gotten it to go was when I was running BOINC, both CPU and GPU processes at the same time. And the highest I was able to get the CPU at that point was, I think I got it to 92 degrees for a little bit. That was about it. That was the highest I've ever gotten it to go, and I was running those processes for about 5 days straight. So the entire cooling system was fully saturated by that point, and I think the highest I got it to go was 92 degrees for the CPU. The GPU, I never got it. I don't think I ever saw it go over. I think I got it to 72 degrees, maybe once or twice, but for the most part, it stays pretty cool too. And like I said, my cooling loop, my water cooling loop, actually cools both the CPU and the GPU. So overall, for the most part, I don't really worry about cooling. It stays perfectly cool all the time, even when it's running these workloads constantly. So it's performing really well for me when it comes down to that stuff. So as far as benchmarks go, I run Geekbench 5 in Linux, and the results that I got for that were 1369 for a single core and 14291 for the multi-core. So you can compare those numbers to other systems. Like I said, I use Arch Linux, and you can see that I'm running on my MSI Prestige X570 Creation board with the 3950 processor. So those are the results of that particular benchmark. I don't have any active benchmarks, so I can play a game or something like that and just fine, even in Linux. I've run the benchmark for like Tomb Raider, and it was perfectly playable. I think I got like 120 frames per second or something like that, which is way more than I'll ever need. So I wasn't too worried about that. As far as static benchmarks go, I use the U-Engine stuff. We'll start from the oldest, which is Sanctuary. That one gave me a score of 2544. Average frames per second. On these older benchmarks, I can't really go, they pretty much peak out at 60. It doesn't go beyond that. But according to the lowest and highest, we got 47 and 63. Same with the Tropics demo. Yeah, I don't know if it even is capable of going over 60 frames a second, but that's the maximum, or the average that it said I got. The score was 1511. Minimum was 35 and maximum was 62. And then as far as Valley, which is a little more modern, that one's 103 average. I got a score of 4340, and 45.5 was the minimum, and 201.9 was the maximum. And then from there I went to Heaven, and that one's fairly well known, and people recognize that one. But I got an average of 97.6, and the score was 2460, and 14.9 was the minimum, and 202.4 was the maximum. So, and then as far, like I said before, I did run a Time Spy benchmark, and the results I got out of that was 9,579, and that was with my Radeon 7 and my Ryzen 9 3950. So those are the static benchmarks that I actually got. Let's see, trying to think of if there's some other benchmark that we should run. Probably the drives. I can do that. We'll run the benchmark on the drive and see what kind of performance we're getting out of that. Alright, and we got benchmark. Let's see what we get out of it. It says 3.4 gigabytes a second for read rate, and that's on the PNY NVMe SSD, or not the SSD, the NVMe drive, the 1 terabyte. That's where I put all my system files, the Linux boot system, the Windows root system, and all that stuff. So that one's getting about 3.4 gigabytes a second read speed. And the 2 terabyte is where I store most of my data. So we'll try that one. That's an NVMe drive, the PNY NVMe drive. And these are running on PCIe 3.0 and not 4.0. So that's saying I'm getting about 3 gigabytes a second of read speed. Access time of 0.03. Which that's what the other one was too. And now for spinning physical disks, I've got the 4 terabyte Western Digital Gold and the 8 terabyte Western Digital Gold. So we'll do the 4 terabyte first. Let's see what we're getting out of that one. Looks like that one got about 187 megabytes a second. And our access times are, looks like we're going to hit about just under 12, just under 11.75 it looks like. So access times on that one are 11.75 on the 4 terabyte and 187 megabytes a second on the read speeds for the 4 terabyte Western Digital Gold. The 8 terabyte, we'll try that one next. Looks like that one got 214 megs for read speeds. And access times looks like it's probably going to be about the same as the other one, about right around 11 milliseconds. I think the other one was 11.75. This one ended up being 11.24, so it's pretty close. But so those are what I'm getting for read-write speeds on the drives. And average temperatures, like I said, I'm usually right around 80 degrees. Right now we're hitting 82, looks like is a maximum. So, but that's the kind of performance I'm getting out of the system at this point. So I just wanted to go through a few little benchmarks like that just for baseline testing. Like I said, I'm not overclocking it, and I'm not looking to milk any, a few ounces of performance out of it. I'm not doing any overclocking or anything like that. All those benchmarks that I was running, like the read speeds on the drives and stuff like that, that was all being done while I'm recording to the drives. So in a real world performance situation, the machine is performing absolutely fantastic for me. I just kind of wanted to give a baseline idea of what kind of performance I'm getting out of it. If you have any questions or comments, just leave them in the comments below, and I'll try to answer them as soon as I can. Thanks for watching. I'll be back pretty soon here with some more videos, because I wanted to actually go ahead and do the individual reviews for each individual component. So I'll be back with those videos. Come back and check them out. Thanks for watching, and come back and watch the other videos.